Good morning, good afternoon all. So this is a joint presentation between the Pistoia Alliance, Agilent and ZONTAL. And we want to show you the progress that we have made on the methods database project. So really building on the work that perhaps you would have seen at the last Allotrope Connect conference, as the methods DB is a semantic model that builds on the Allotrope standard. We want to show you the current state of the POC work that we are doing with Agilent and ZONTAL, and some of the next steps with Merck and GSK. And we have also a live demo planned for you of the methods adapters that we have developed. And I will just be going through a little bit about the background of the project. So I'm Birte Nielsen from the Pistoia Alliance, and I'm co-presenting with Heiko Fessenmeier from Agilent and Wolfgang Kolsmann from ZONTAL. So just briefly about the Pistoia Alliance, I want to mention that it is a global non-for-profit and pre-competitive alliance that really collaborates to lower the barriers to innovation in life science and healthcare R&D. And we work with and we are made up of many of the leading pharmaceutical companies and vendors. And I should probably also say that I work with Gerhard Nolken on the MethodDB project. So if you have seen some of these slides before, it's because I have taken them from Gerhard. So what is the methods database and why are we building these methods adapters? So approximately 3 years ago, the MethodDB group, they built a data model or an ontology to support analytical HPLC UV methods. HPLC or high performance liquid chromatography, it's a technique that scientists they use in the pharmaceutical industry. And they use it to separate, to quantify, to identify each component in a mixture in a drug formulation. And you really want to be able to move this method around, maintaining the reproducibility. And data reproducibility is a really massive and costly problem in life science. Unfortunately, many of the methods of these analytical methods, they are manually kept and managed. And if you have a digital copy of this method, it's usually stored in some kind of proprietary platform. But with the MethodDB project, we want to move away from text-based analytical method descriptions to something that is fully digitalized, something that the machine can read itself. So instructions for an HPLC that is completely automated. So we want to improve the automation side. We want to improve the interoperability as well, to improve the overall quality, to optimize the efficiency and therefore reduce the cost. So how are we going to do that? So we want to improve how pharma companies they transfer these methods. We want to be able to freely share these digital methods, not only within the company, but also outside of the organization to, for example, a CRO. CROs are actually carrying out the majority of the analytical work for the pharma companies. So we want to enable a fully digital business-to-business method transfer. We want really to be able to send the parameters of a method instruction to the CDS system completely automatically for the machine to execute this method, regardless of the vendor or the CDS system. And if we can do the same with results, which is actually something that we're working on at the moment, you are now able to carry out some advanced analytics, which you really need for your out-of-spec analysis. Vendors, they have really only focused on results so far, and it's very important that we do not forget the method parameters as well. The method is developed quite early on in the drug development process, and then this method gets moved around and get modified, and we really need to document this correctly. So if we have an electronic version of this method, with an ontology and the allotrope data format platform, we now have a digital standard that we can build on. So to show you a little bit about what we did, you can see here we have a very simplistic illustration of a HPLC system, and there are certain parameters that would make up this system. So for example, you have the solvent or the mixture of solvent that you need for your separation. You have a specific pump flow. You have an injection volume. We want to know about the chemistry of the column, the settings for the UV detector. So a team of researchers or chromatographers, they got together, they named these parameters, and they got them defined, and they built up the semantic data model. And you can see here that the semantic data model, it does represent the HPLC method. We applied the allotrope data modeling patterns to build the graph structures of the method descriptions, and many of these parameters that relate to the method information, they are represented by these objects that carries so they would carry like a numerical value and a unit. So for example, the injection volume, it's for example 0.5 of a mil. Yeah. And so the semantic data model, it contains approximately 55 or 57 HPLC parameters in the version that will go live next month. In an earlier POC, we did show that it works, and we have shown that it represents the most important pieces of your HPLC method. So the second phase of the project was really to get the vendors on board and to build the adapters to these different instruments. So for example, you have the Waters mPower adapter here, so that will allow you to download the method from the water instrument, and then you can upload this method into the methods database, which we have in ZONTAL space. And then you can now download the method into, for example, an Agilent Open Lab CDS, and then execute the method there. And with the MethodDB here, you have the ability to search and report as well. And as I mentioned, we have now 55 parameters, and all these parameters allows you to link your sequence that you're working with to your ELN or to your LIMS system. We're also in the early stages of developing a chromatographic column data model for column metadata, and we have actually full support for the entire sequence and not just a single injection. So to summarize that, and just to really highlight the overall aim of the MethodDB project, you have here your LIMS, your ELN, or your workflow system, and you then send your sample information to your control system, which is your CDS. We want to include sample prep as well. Sample prep can be a little bit more difficult, of course, to standardize, but it's something that we are working on. You then have your CDS that then talks to the methods database, and then you can up and download the method information. You can send this information next door. You can send it outside of your organization, regardless of the type of instrument you're working with, and it's then shared in this corporate database. By the end of the year, we are also going to have adapter versions that fully will report data and results. And we have been working with natural language processing so that we can extract important sample prep and methods parameters. And we have gained a little bit of experience of that over the past 6 months as we have a POC on that. And as I said, with the methods parameters and with the results data now in one place, we are really getting to the whole point of this project, which is that we can now start using some artificial intelligence to monitor the performance of your analytical assays, and also looking at out of spec analysis, finding reasons why an essay didn't work. And with, with this data model in our ADF format, I think, we are truly changing the way that we are working with analytical methods. So my last slide is really just showing where in the Pistoia Alliance the methods DB sits. So we have the methods hub, and we have different working groups here. So the methods database. So as I said, we are ready for the pilot implementation. We have the chromatographic column data model, where we are just building now the data model for column metadata, and then the POC on our methods on demand for for natural language processing. Of course, the Pistoia Alliance also, of course, have lots of other projects and has actually started a new project on IDMP ontology as well, which really is driven, I guess, for a need to standardize medical product definitions as well. So with that, I'm going to hand over to Wolfgang.
Maybe you want to drive, do you want to drive the slides? Yeah. So for the proof of concept, we have identified several scenarios how member companies can deploy the solution. So on the left-hand side, here you can see that for scenario number 1, we can use the OpenLab CDS as a workstation, which can be installed on a virtual machine or on a laptop, which helps to solve some of the IT security related issues by getting access to the cloud. We then can have the methods database installed either in the public cloud or on your private cloud, and then both systems can exchange the method, so from the CDS system to the method database and back. So that's the first scenario. If you can move to the next slide. The second scenario would use the OpenLab CDS server version and the sample scheduler software, which then allows us to send a sample sequence, the method, and also then receive the results. So this would then be the closed loop system here that Berta presented in the previous few slides, where we're going to really start from the request for a measurement through the whole process and retrieve the results into the system in the end. Next slide, please. For the Empower integration, we will introduce an additional adapter built by Orbis Lab Systems, which will allow to send methods to Empower and receive the results from Empower in a vendor-neutral representation. So similar to the previous scenario, this will allow us then to integrate with LIMS-ELN or other workflow systems to receive a request for analysis, manage the method lifecycle, and receive the results. Next slide, please. Heiko, do you want to take it from here?
Hello. So I will present you the current version of the allotrope method export import. So we have already presented that some while ago, and what happened since then. So from the US user perspective, you probably won't see too much different than what has been shown before, but behind the scenes, a lot of things have changed. So we have updated the allotrope method graph according to the latest method data model, which was a significant change since we had a prototype model before. So we wrote the method import and export code from scratch. So to read methods, so we added for the pump the gradient table, and more and more of the Agilent specific parameters got added. So we currently support much more than the ones that are that have been specified by the Pistoia Alliance, and the ones we have added are Agilent specific parameters, and that gave us the possibility to start with an Agilent taxonomy regarding method parameters, and that was also used by ZONTAL then to pass the information and to visualize the method information, as you will see later, presented by Wolfgang. So that's what happened so far, and I would like to show you some demo, and maybe you can give me the presenter role. Thank you. And go to, so can you see the screen?
Yes.
Yeah, okay. So just a refresh. So I will show you the export and the import workflow, both with OpenLab CDS. So I have an Agilent HPLC and a method created within OpenLab CDS. I will export that method into an ADF. We'll upload this to the Pistoia method database, which is represented by the ZONTAL space. Then afterwards, I will switch to the import workflow. So I will download this ADF from the ZONTAL space to my local download folder, and then import it into OpenLab CDS, and then I can visualize that in my OpenLab CDS acquisition client. So let me switch to the machine. So we have here the OpenLab CDS acquisition client. Usually you'll see it like this when it's installed out of the box, and we have installed an ADF-LC method export import plugin. So that is represented here by this pane. So I have one method prepared. Let me open that. So this is the method. So you can see here the pump, the sampler, the column oven, the DAD, the gradient, the pump. The gradient pump has the flow solvent definitions. Here the timetable of the gradient, the injection volume. So I have chosen a little bit strange numbers to make it visible that it's really imported at a later point in time. Then the temperature of the column oven and the DAD wavelength parameters. So that's the method I want to export, and let me export that. So I select the method to be exported, and it's getting exported then to a local folder. In this demo I show today, the upload is manual activity, but as it was mentioned before, we will make this for the evaluation or for the proof of concept a little bit more automated. So what you can see here in the folder, I have exported that to a certain folder. Let me do another method export. So that's really done in a few seconds. So you can see method export is ongoing, and then it's done. So you can see here's the second one. And let me upload that to the ZONTAL space. So I switch to the ingestion pane and then upload that. As I said, this is currently manually, but we will do that in a more automated fashion later. So I submit this for ingestion. So it's ingested, and you will see that it's upcoming into the space in a few seconds. You will see this here on the right upper side that it has been received and integrated. So that means incorporated, so it's there. And I think it's this one. So you can see here the method, and details of the method will be shown by Wolfgang later. So I just wanted to make sure that you see that it has been imported. So let me now switch to the import workflow. For this, I download the ADF from ZONTAL space to my local download folder. It has been downloaded. You can see it here. And then I will switch over back to the OpenLab CDS acquisition client, and to show you that it has actually been, or it will be actually been correctly imported, I have prepared a method. So you will always require some kind of a base method, since often you cannot import all the parameters, or the ADF might provide less parameters than actually required for an Agilent LC. So here with this base method, you can pick the method or modify a method to your needs. You can already set some parameters you want to have as a base. And you can see here the signals that are all switched off. The gradient pump, nothing is in there. The gradient table is empty. And I will import the ADF into this method. So I will select the method import. First, I have to pick the base method. So that's the one I have shown just before. The second step is to select the ADF method to import. So that's the download ADF I have picked. And so the method is ongoing. It has been successfully imported from the ADF. And then I have to save this as a new method. And let me pick a new name. So it's the imported 06, successfully stored, and then let me show that. So as you can see here, we had empty flow, empty solvents, empty gradient tables before. That has been filled out and imported correctly. The sampler, you can see the column open, you can see DAD. Oh, that doesn't work. Okay, I think I have picked the one, but I can show you one that has been imported before where this works properly. So this is the one where you can see the methods for the base length parameters. So that shows that the things have been imported correctly. And this is the workflow of the export import. And that's what I wanted to show you today. Thank you for your attention. And
thank you, Jamie. Can you make me presenter, please? Thank you. So we have presented the integration of the methods into ZONTAL previously. What I want to show you today is how we have now extended the methods database to allow you to actually look into the methods file. So we see here that we have the methods file provided by Heiko. The methods have been provided by both Merck and GSK. So we can really see now that we have one database that can be used to exchange and transfer methods between different organizations. And if I select any of these methods, as Heiko has demonstrated, we see a few parameters that we have extracted here just to visualize them. But now with the new capability, we can completely look into the method description. So we see the 4 modules of the HPLC stack that Heiko has also presented in the CDS system. And for each of these modules, we can then have a visualization of the graph model with the parameters that have been defined. So we see the autosampler, we see all the parameters about the detector. We can see the pump and the liquid phase, including here also the gradient table for the mobile phase delivery. And we can see the oven parameters. So the next step then will be that we do the same for mPower. So this will then allow us to not only exchange methods across organizations, but also across the different vendor software systems. What we have also provided is a representation of the results. So we can see here that we have both methods and one result data set in the system. Again, the result data set has extracted a few metadata terms that we can also use for search. So for example, if I search for Heiko and click on that sample, the system suggests it automatically detects that this is a term from the ontology. So it's our sample that we have identified here, and we can then open this result data set in ZONTAL to actually look into the ADF file, what's inside. So we have all the information about the software version. We have information about the instrument modules represented, and then we have information about the actual injection. So here we have a single injection and the measurement provides us with 2 chromatograms, so we can select the chromatogram and the system will provide graphical preview here. And we have also then information about the peak list. So in the simple data set, there's only 1 peak inside, but here we see all the peak parameters that are provided. What we can also see is the link to the ontology. So if we go onto any of those column headers, we will see the concept and the predicate that are linked to that property. So this allows us then to navigate to the documentation of each of those terms, so that the data scientist needs less communication, or hopefully finally no communication, to business or IT to understand the data and the data models behind the data. So next steps at Merck and GSK is now to integrate the Agilent proof of concept configuration into the laboratories, and then later this year, and also automate the integration, so that the method export functionality from the CDS system automatically does the upload to ZONTAL. And then later this year, once the Empower adapter becomes available, to add the Empower system to the setup. Britt already mentioned the second project in the Methods Hub framework in Pistoia, which is the Methods on Demand. So we are ready to run some proof of concepts here as well, with the goal to not only have a digital representation of the method, but allow it to convert paper-based methods to the digital representation, to make those methods then available not only to CDS systems, but also, for example, to LIMS system, ELN systems, or execution systems to help automate the workflow execution. This can consist of 2 parts, so we can digitize existing paper-based methods using document scanning and OCR, and then in the second phase for the digitalization, then we use NLP technologies to extract the semantic model from those documents and provide them in the Allotrope data standard then to any application that needs to be integrated. So with this, I come to the end of our presentation. Not sure if we have time for questions. If not, just reach out to us via email. Thank you.